point in EXIGENCE was to introduce an energy information observability layer, which would be able to capture the service level energy information. So that was a differentiator compared to previous efforts where usually people would be measuring, let's say, at some domain level, within some boundaries, within some maybe geographical or any other separation of the landscape of the ICT service. We positioned EXIGENCE from the very beginning at the service level. The service can obviously span several technical domains, authoritative domains, and we try to measure exactly the energy pertaining to that particular service flow and or service session. So why is that important? Because it allows us essentially to show to the user the impact that that user in particular is creating, which is then very important not only for the B2C but also for the B2B sector, where you can precisely weigh off different options that you might have, for example, on-prem or in the cloud, and the ecological aspects, which was not possible before. So we also kind of compensated this first step, the most important step, this observability at the service layer, through incentives which come at the service layer as well. So we can incentivize users actively to do something different than they would be doing otherwise. So we internalize, for example, the carbon cost through this incentivization, allowing us to then cooperatively reduce the overall energy consumption. So this interesting concept, they work together with local optimization within the domain, and overall we could achieve something which we call cooperative energy reduction, which was not possible before and would not be possible without the service layer abstraction that we're using. Huawei's role in this is quite obvious. So first of all, we were kind of at the very beginning, at the inception phase of the project, creators of the idea and so on. We pushed it forward. We're acting as a technical manager or deputy technical manager in this project. We contributed a lot to several aspects of this project, including local optimization, but also, most importantly, to the end-to-end demo setup. For us, as a major ICT vendor, it's very important to understand the, let's say, feasibility of such a new concept, its potential. So what are we actually getting from this? How far can it go? How much energy can we cut through this combination of the three pillars that I mentioned before? But also, of course, the value on the market, the business value. And to enable the latter, through this project and during the work of the project, we actually went into different technical domains, such as 3GPP, but also IETF and ETSI, to enable requirement engineering and to formulate new requirements stemming from this need for service level observation of energy readings. And we kind of, as a project, were quite successful formulating several such requirements, notably for the future 6G system, which are now in the normative document of 6G standard work.
We find energy efficiency and sustainability of ICT system very important. But in order to control and minimize it, we need to make visible the energy consumption of communication service, not only measure their performance. So this is what we really aim at with EXIGENCE, to quantify it as in a first step. Secondly, make some optimizations with the visibility information we can extract from the systems, and at the end also inform users that communication systems are really using energy and it's impacting our societies and our environment.
I would like to introduce to you the EXIGENCE project and the demonstration and the proof of concept we have developed. So a quick wrap up first. EXIGENCE is about reducing energy consumption and CO2 emissions of ICT services. And as we know, ICT services have been a big contributor to energy consumption increase. And our project doesn't work on improving efficiency because that will drive the demand. We work on improving the utilization of the system and reducing the demand by basically following three pillars. We would like to measure, optimize, and incentivize. So for the measurement, we have developed a proof of concept that can measure the energy consumption of the major use cases on the internet. First one is the video streaming use case and an AI use case. So for the video streaming use case, we're able to measure the end-to-end energy consumption over a 5G network. And as we can see here, we're able to track the energy consumption of the service of the video stream to that specific user. And for the AI inference, we're able to track the energy consumption and the CO2 emissions for a specific prompt. As we know, the AI services are quite important these days. We would like to track the energy consumption and deliver that information to the end user. So the last step is the optimization. So what we can do is basically we can redirect the users to servers which are fed with green energy. And we do that by using an orchestrator that by activating the low carbon variant of the system, we're able to redirect the users to that server featuring the large language model, which is fed with green energy. For example, solar energy or wind energy. And if we do that, we'll query the orchestrator, get the information about the different service variants, meaning that we have different servers with different energy sources, and we get the optimization strategies that would help the user satisfy the needs. And in this case, the need would be to go to a server with a low carbon footprint. And usually we're getting something like a carbon footprint of 7 milligrams CO2 per prompt. And as we see, after activating the low carbon server, we're able to drop that to almost zero by basically using the information from the network about the energy consumption of the different data centers and providing that for the orchestrator.
Well, so Internet Institute is primarily being focused to work package 2, which is about metering, development of metering methods, including the implementation of tools and prototypes. So in that regard, we have first started with defining the metrics which are necessary to fit the EXIGENCE overall perspective to the measurement or to provide the measurement of the energy consumption of the level of services and end users. So as said, we have mainly contributed in developing the methods and implementing the tools, which were further deployed in our 5G testbed. So showing the use case of streaming the video on end-to-end. And by this, we see some future in this, first by further development of these prototypes to be included into our existing measurement set of tools. And there is also another perspective, let's say somehow more wider, which has been partially also already explored within the EXIGENCE, which is to utilize this data, so user level and service level energy consumption, fit into the AI models. So in order to optimize on the one end the complete service delivery chain, so all the components that are included in service delivery chain, as well as for the specific user or specific service provider in order to reduce its energy and of course reduce carbon footprint.
In my opinion, to ensure energy efficiency while preserving quality of service, we have to forget everything about traditional orchestration and try to adapt to 6G networks. So at the National Competition University of Athens, at NKUA, we have adapted, we have developed some advanced frameworks as part of the EXIGENCE project to face this particular challenge. So firstly, we have developed Green Flag for distributed AI training. Green Flag relies on reinforcement learning to dynamically allocate resources at network devices while also taking into account and taking advantage of locally harvested renewable energy such as wind and solar energy. So for our evaluation results, we have achieved up to 95% on grid energy reduction compared to 3 other state-of-the-art baselines. Now, secondly, for AI complex services, we have developed 𝗁𝗿𝗂𝗋𝗋, which is a hierarchical genetic algorithm framework. Now, instead of overloading a single device in the network, 𝗁𝗿𝗂𝗋𝗋 manages smaller AI partitions. And first, 𝗁𝗿𝗂𝗋𝗋 distributes these partitions across a mesh of network devices, and then it proceeds with resource allocation per each partition. For our evaluation results, we have achieved over 80% of total energy reduction under heavy loads, while also eliminating all network failures. Of course, taking into account real-time latency thresholds. So all in all, if we adapt these sustainability-driven orchestration mechanisms, we can actively support the EXIGENCE goal, which is to reduce the total energy consumption and the carbon footprint emissions of ICT services.
Telefonica is bringing to the project the service provider view. Our goal here is to understand how the way of measuring the energy to be allocated per service, so that we can contribute to the social responsibility of the customers, individual ones, thinking on residential services, or the big companies thinking on corporate services. With that information, we can take later on decisions, we can try to optimize the network, we can try to incentivize the users for also pursuing these sustainability goals. And apart from that, something relevant for us, for Telefonica, is to contribute to standardization bodies so that we can enable the means of measuring and collecting the information from the network.
How do we see that EXIGENCE is and what we expect out of EXIGENCE? We keep on talking about sustainable societies, about energy consumption, about being better for the world, but this is extremely hard to achieve. Now, we need to be able to define methodologies, getting ways of achieving metrics, and then act on those metrics in order to lead to a more sustainable society. Now, saying this is what we expect from EXIGENCE, and I'm very glad to say that we have achieved that. And in fact, in my institution, we were a component in developing some of the key demonstrations and some of the key technologies that EXIGENCE is deploying. And we have been deeply engaged in some of our demos, including the green AI aspects, which are so critical and so famous today in terms of the perception of society. And why are we doing this? Well, we are a research institute. Our institution is mandated to bring innovations that are coming from the academia and from the scientific world towards real concrete results which can be further exploited by society. That's what Institute Telecommunications is, which is a leading institution in Portugal for the area of ICT technology and the development of the Portuguese society on the area, and I'm very glad to say for the development of Europe and the world in general. So in a summary, our role is, according to our mandate, going to transfer innovation and research into tangible results. We are addressing the challenges of real impact of energy into society as a whole, and to address the specific mechanisms that we can use to make these more than empty words. And in EXIGENCE, we were able to demonstrate that with a set of novel technologies and with real demonstrations running on data centers where we can see the added value that we bring to society in general, and hopefully through standardization to the world.